Alright, welcome back to another stream session of Unity 3D game development with me, Johnny Rush. Alright, welcome back to another stream session of Unity 3D game development with me. Just turn up this volume. I forgot to mute my volume. Actually, I'm watching the stream to make sure the live feed is coming through correctly. And I had the audio in, so it was coming through my headset as I was speaking. Anyways, yeah, welcome. I'm actually Michael Trippy. I go by my online handle, or Johnny Rush, which is generally used in some of the games I play, but I felt I just carried over to this as well. So I'll respond to either Johnny or Mike, either one. Anyways, so what I want to go over is basically the final changes that I wound up having to make in order to finish our spawning system. Initially, if you were following the other previous streams we did, when we started the spawn system, I created some functionality in the inventory manager script that would basically find all the spawn locations in the map and spawn a random item in it. But it didn't have any ability to once down the road, if we're looking at picking up items, and there was no way to respawn, and since that was done globally across the entire map, it couldn't really be applied or useful in any way. So I decided to take a lot of the code that I had that was working and break that down into a single function called SpawnItem. Jump into the inventory manager. So yeah, here's our single function here called SpawnItem. And what it takes is two parameters are passed into this function. One is the spawn location, which is of type GameObject, and another is a string array, basically of the filter categories, which would allow us to specify what categories of inventory items we want to be able to spawn at that particular location. Currently I have set up, let's scroll up to the top here, these are the 6 inventory types that are set up. And I still got work to do on that. I'm looking to have an easy way to access those, but anyways, what's passed into the function is a string array of any of these keywords right here for the categories, and these are closely tied to the inventory items. Every time we add an inventory item to our master inventory file or folder in Unity, which I'll show that here. See if we can stretch that over. Our master inventory, these are the ones we have. Yeah, so every time we add one, we attach this inventory item attribute script to the item, and then we set some values, the category that it belongs to, and all that. Now so this is where these category names come in. We just specify what category that's from. Now, the category names are specified at the spawn locations as to what items we want to use, but these are the keywords I currently have set up, and later on we'll expand that. So let's go back down to our SpawnItem functionality. And what I found, in the end of the last series, I did create some of these scripts, like the spawn location attributes, our inventory item, we had that, and we attached the inventory item attribute script here, gets attached to the items that are in that master inventory folder. And there's some values that we set. These are the public ones that show up in the inspector that we can set. Now these are 2 that are private. And they are set when an item is being spawned from the spawn location, it will access these private variables, well, specifically the lifetime variable, and set up a default lifetime for that. Now, in the event it's set to 0, which would mean it wouldn't even spawn, because immediately as soon as its lifetime is set to 0, it would get despawned based on the logic I have set up here. The lifetime is 0, well then, the current time is always going to be greater than the lifetime, and it would destroy it immediately. And that's kind of what was happening. It's creating and destroying these objects super fast, and at some point I wound up locking up the program, I remember. But I went through and had to make some changes to the code, and now these are private variables here that cannot. This one here is private, so it cannot be accessed directly. So I set up these two helper functions. One is called set lifetime. It's a public, so it can be utilized outside this class and another class or script. And so the way it works, you just pass in the value of the lifetime, what you want it to be, and that value is then assigned to our m_lifetime private member variable right here. So, and that stays with that item when it's spawned. It stays with that object. That script is perpetually attached to that item until it's destroyed in the world. And so this would be anything that needs to happen with items while they're being spawned in. This is where the code would be set up. Now, in the start function, which is called the first time this object is instantiated, we initially set the start time. So we have a start time. We make that equal to time. And I also check the lifetime. If for whatever reason it's not set at this point, 0, I set it to 60 as a default, but that gets overridden in the code. There's some code I'll show you in a bit in the spawn location attribute file that will override that to whatever the spawn is set up to do. Now right now I have anyways, I'll come back to that in just a minute. And now this private update, void update, is run once per game frame. So it does a check, takes the current time at that game frame, subtracts whatever the start time was, and so you'll come up with a difference there. And if that's greater than the lifetime, which is specified in seconds here, the value that comes in is in seconds, and so then it will log some information about destroying the object, and it actually destroys that game object, and so it ends its life, and it disappears out of the world. So that all works great. Let's go to the spawn location. And so you see here we have public string. We got a category, which we can set up multiple categories, frequency, and the lifetime. Last spawn time. That's used internally in the spawn location script, similar to the way the start time is used here. We've got to track the last time the spawn actually spawned an item, so we use this last spawn time variable to hold that, and it's not actually set until after the first item is spawned here. Down here we set the last spawn time to the current time at that point. And so initially it starts at 0, so of course time.time minus starting point of 0. If it's greater than the frequency, then it'll start spawning. Now this time.time value is the time at the beginning of this frame. This is the time in seconds since the start of the game. This is not. It's a great thing. It actually starts a timer. Unity has this thing that starts a timer when you launch your application. It immediately starts the time. And so there's a running time going on. So this is not like other languages that you may have programmed in if you're a programmer, like C#, C++, C, etc., where the timer that you have is actually the real time on the clock, and so you've got to do your time calculations a little bit differently. This is easy here because it's the current time since the game started. You just subtract the last time spawn, and gives you a difference. And if it's greater than frequency, then it will spawn. So the frequency, again, it's a public variable, and you'll see because these are public, these three show up in the inspector for the spawn location. So once you add a spawn location to this world, to this project, this Unity project, anytime we add one, and we can't actually see on our building, when it's sort of as a prefab, we don't actually see all the spawn locations, but they're grouped together in what's called an item spawn group that I set up. But I can pull again. You've seen me do this. I can just pull in an instance in the editor here, so we can take a look at it. If we expand it out and go to the item spawns, click spawn 1, you'll see where category shows up, frequency and lifetime. The category, again, it's an array, so it immediately sets up a size of 1, but I can change that and expand to put as many categories of inventory that I want to allow. Each inventory category that I want to allow would need to be on its own line. It will be element 0, 1, 2, 3, 4, etc. if I were adding additional ones. But for this spawn 1 only spawns ammo, spawn 2 ammo, spawn 3 a consumable, spawn 4 weapon primary, and spawn 5 I'm actually doing 2 different items that can spawn, which is the weapon secondary and an attachment. Now, like I said, initially when this is launched, we took away the function that just randomly generates items all over the spawn locations right from the start. So that's gone. So initially when this is run, because the script starts, we have a frequency of 60. And our last spawn time is going to be 0. Well, we're not going to get an object that will spawn immediately here right away. It has to wait until 60 seconds passes, the way it's set up right now. Now there's an easy change that we can make, and we'll do that in this session, so that it initially spawns an item, and then it'll start going from there. So let's jump back to the designer here. So item 5 does 2 different ones, and I've got the frequency set up like that. Now what I want to do, so we can actually see this in motion a little bit better, and we want to see how quickly these things spawn. Let's change that. Say the frequency is 15, lifetime 10. I've also noticed, just so you know, I've also noticed, at least in the Unity editor here, maybe when I compile the program it will be different. What I noticed is that destruction of objects does not occur precisely like I would expect them to. Sometimes they're off by a little bit. And the reading I've done, because there's so many of these scripts and so many internal scripts that are built into their components, they have the update function may or may not run as often as you think, because of other things like CPU load and that could change the duration of the update frame. And so your frames could drop and you don't get it. Anyways, it doesn't run as often. Sometimes it's delayed, and it seems like it's, if I have a stopwatch on my phone I was using here, and when I saw an item despawn, I went ahead and hit the start to see does it actually respawn in the time I'm expecting, especially when it is destroyed at 10 seconds. So the lifetime is 10 seconds. These objects should destroy in 10 seconds, and a new one should respawn in 15. So we're going to time that. We're going to do some time trials here. Let's see if there's a stopwatch. No, it's really not. I have to download something. It'd be nice to have one in here that I could just run. Anyways, yeah, so let's go ahead and just apply all those changes from this instance that will apply it back to the prefab. So we update those values for the spawns, and now let's delete that. All right. Now we're going to go back to our script real quick. And so, yeah, that's the inventory item attributes. You see, it's very simple. We simply have, we have some variables we can set on that that'll be used later. We're currently not using a lot of these. Matter of fact, none of these are currently used, but you can set the values so they're ready to be used in our world. And so we'll build around those and build the functionality that will take advantage of those. But what it does use right now is the category, so that during the spawn process, it'll use that category to pick out or filter out items out of the master inventory that we've set up and spawn them in the world. All right, so that's pretty simple. Now the spawn location, let's take a quick look at that again. All right, so what we're doing, one of the changes I had done is, because this could have been causing part of the issue, I don't know for sure, but this inventory manager here, first of all, I had it defined as just it was inventory manager IM, and if you take this line right here and prefix it with this part right here, this part, basically I had that line of code down here in the update. It was down here that right before it would spawn an item, it would grab that inventory manager and do it every frame. It was kind of doing it like during the update, which this could happen 60 times a second. And so it was getting a new instance of that item 60 times a second, or whatever frame rate I was running at. I don't actually have a frame counter running. And so it was, that was one thing that was causing excessive use of that class. It was getting a reference, but it was doing it like every update, and I think it was eventually causing it to hang at some point. So I changed it a little bit. Number one, I only need one copy of the inventory manager. There's only one copy anyways. And the only function we're using that's a public function within inventory manager is the SpawnItem function we generated earlier, or created earlier. So so I set it up top here, created a variable up top here at the class, and in the start function, which is only called one time, it will actually get a reference to that inventory manager. And I added this keyword static to here because just another optimization thing here. Because the way the static works, we have the spawn location attributes script applied to every single spawn location game object that we have. Right now we only have 5 in this, this little world we've set up. It's in the building, the sample building we have. But there's no need to have each one of these scripts get a reference internally to that inventory manager. And if we had thousands of inventory managers, we'd have thousands of references of that set up or objects, copies of it. And anyway, so I set it up as a static, because what static does is it will maintain that copy of that particular variable or data type across instances of the class script, the spawn location attribute. So essentially we can have 1,000 spawns that are spawning a copy of this. They have their own unique copy of the script, but they're sharing the same inventory manager object, if that makes sense. So and so when we scale up, we're not going to be grabbing an instance of that inventory manager for each spawn. So that was one minor change I made. And then again in the start, it does this, and so so that'll be the same variable. And I'm almost thinking we could probably move that right up on the line we define it, so it won't even be called in start each time, because essentially I guess that would be, the variable is static, IM, it's going to be reassigning the contents of that, that variable. So it probably would work that way. I'm almost reluctant to change it because it is working right now. But let's go ahead and do that anyway. I'll know to change it back if it locks up. Let's drop that in here. So that'll just be called and set one time. So we have a static inventory manager object set up, and it's going to be shared by all instances of the spawn location attribute script that's attached to any spawn location in this world. And that's that. And so then in the update, we're doing like we did in the inventory item. We're doing time.time, which is the current time since the game started, minus our last spawn time, which initially starts at 0. If it's greater than the frequency, which it won't be, because as soon as the game launches, time.time, if the theoretical start is 0, so 0 minus 0 is still 0. It's never, so it's going to take the frequency is the length of time it'll take before an item spawns, and that's another reason why I just reduced the frequencies from 60 seconds to 15, so when we run this, we can see items spawn quicker. But like I said, we'll make a change that will allow us to spawn an item immediately, and then go off the frequency after that. And so I have some debug statements. You can ignore a lot of this. This here isn't the debugs, of course, aren't the actual code. These are just things that are logging to the console, so that I can, while this is running, I can look at the console and see messages popping up, or review it after I stop or pause the game. So it's very helpful to log out anything you're doing, especially when you're having bugs and glitches like I did last time, where the entire thing locked up my system, or actually didn't lock up my system, it locked up Unity and wouldn't do anything. So essentially what we're doing, once we meet this criteria, it's greater than the frequency, we check to make sure that our inventory manager object is not equal to null, which means it's been, we want to make sure there's an actual inventory manager object there. And if there is, then we can call the function called SpawnItem that's been publicly exposed to other scripts. So we call that function passing in this.game object, which will pass in the game object reference for this spawn location. And the second parameter we pass in is what we've set m_category to, which is coming from the inspector on the spawn location. So, and then we update because once we spawn an item, we want to update the last spawn time to whatever the current game time is. And so that'll cause this if statement then to wait again until the current time minus the spawn time is greater than our frequency. So that'll make sure that all works. So very simple script, really. All right. And so let's take a look at Inventory Manager, or Spawn Item. I don't know if I went through that, but essentially it's doing similar stuff. It's making sure the spawn that's passed in, I've set up a variable called spawn on this side of the function, inside the function, and that's what we check. We're checking to make sure the spawn is actually an object. It's going to be a game object. We want to make sure it has some kind of value in there. If it's set to null, that means it's an uninitialized variable name, which means something happened. Something didn't get passed in or whatever. So it's always good to do those checks. Otherwise, you'll get those exception errors you see quite a bit in applications and programs if you try to access a variable, which is basically reference a memory location. And if it has invalid data there that doesn't make sense to the program, it will get an exception error in most cases. So you definitely want to check those. And so the code is similar. We went over this last time. It's the same as the code we wrote for the spawn items, plural, function, except for the fact that we're no longer doing the for each. I commented that out, replaced it with this here that we're checking to make sure. We probably should have had this check in the other one as well, which I think we do. But we're checking to make sure there's at least one item in the master inventory. If we don't have any items in the master inventory set up, then we're not even going to do all this code. There's no sense doing it. But again, it does the same thing as the other one. Gets a random value, makes an index value in the range of 0 to the whatever our count is of inventory. So it'll be whatever that is, somewhere 0 and actually -1 from count. So if count is 7 items, it'll be 0 to 6. That'll be the range. And then we're checking our filter flags. If we're filtering all, which then we would just skip this whole block here from here up. Because what this essentially is doing is we're not filtering, like if we're not allowing all categories of items, if we have specific category items set, then we don't need to do this. But if not, if there's a specific category that has been set, then what we're doing is going through here, filtering by the item, and essentially we're looping through our categories and seeing if the category that was passed in matches one of our categories. If it does, then we set the filter item to true. If it doesn't match, then we get the another random value from our inventory, and we keep looping until we find an item that matches the category that it's trying to filter by. That's essentially what it's doing. So anyways, once that's done, and either of these is true, either we're filtering all, so we're going to just spawn whatever the first item is we found, or if we're filtering a specific item, it'll jump in here and do the actual spawning of the item. And now this part hasn't changed. What I did add, I don't know if I had these lines in here of code before in the last session, but anyways, what the first one does here, spawn location attributes, what it's doing is off the spawn object that's being passed in, it's extracting a copy of the spawn location attributes script data. So anything that's been marked as public is accessible when you get that component, that script component. And so, and then the same with the inventory item. I'm getting the inventory item attribute script component off the inventory item, which is the item here that on our prefab, which we just instantiated here with this line. So we get a reference to it through this obj variable. So we get that reference of its inventory item attributes, the ones that are only publicly available. And one of these is a function that we went over a little while ago called setLifetime. That allows this function, the SpawnItem function, to be able to access the item details on the item and set its lifetime to the lifetime that's been specified in the spawn location, which is, again, it's spawn details, what I call the variable. And then we set the object, there's a setActive function on all game objects that you can pass it a true or false value to set them active or inactive. And we set it to true to activate what happened here. What did I do? Let's undo edit. I guess I accidentally modified something. Anyway, so we set the object to active, and we're good. Now, this line I know I did not have before because my prefabs were already set active in the inventory. So this is something I want to point out so that you don't run into the same problem I had. If your objects are active and you're actually instantiating them in code, they immediately become active then in your game world, which means any scripts that are attached to them that are active immediately start executing. So if you don't want that to occur, which in some cases or a lot of cases you probably don't, because you might need to set some dynamic variables from other sources, such as what we're doing here with the spawn. We're getting a lifetime value from the spawn location of this object and applying it to the lifetime variable that's in that item and that we're instantiating here into the world. So we're spawning. So you want to make sure you wait and you actually. So what I did was I unchecked the box in the prefab. Let me go back there and show you. If we go look at the master inventory, that's why you don't see any images here on any of these items. at the very top here and check that box. So none of this is active. The entire object is disabled at that point. You can still create an instance of it, but it's not visible and active in the game world. It's kind of sitting on standby. So that allowed me to then, get these two other components and then use this function to apply, which this is something I wrote, the set lifetime, to set the lifetime of that item that's being spawned in the world. And then we set it active, which sets it free to go active. And so the other glitch I had, which compounded the problem I had before with items just spawning infinitely, was like I said, the lifetime by default was 0. And see, once the object was already spawned, even though I had this line in here, I think I did try to add it where it would set the lifetime, but it wasn't working because the object had already been spawned in, and by the time I was getting ready to set it, it destroyed itself. It was all slated to be destroyed. Let's put it that way. And by the time the update finished, and it actually does everything to finish out that frame, it's doing it more or less in sequence based on the commands I gave it, and so it was already destroyed by the time it came across these other lines of code and whatever it did. But that's my theory on what happened. It's more likely what happened, and it makes sense. And I even did some debug statements to write out after. Matter of fact, right here, I don't have them here, but I had them in there earlier. I took them out, but it was showing the lifetime value. Actually, I think I do that in the inventory item, but yeah, it would show the lifetime before and after, and it was showing it was at 0, and then it was applied to another value, but it didn't matter because once it was 0, it got destroyed after the frame, so that caused some of the issue. But so let's go ahead and run this. So that's the basic code, and so the way this works again, just so we can kind of review. When we add a new item into our master inventory, which would be just a 3D model from anywhere, we can drop it in. We add this script, inventory item attributes, as a component to that item, and then drag it over. We create a prefab out of it after we add that script. So, and then delete the instance that's in your game scene because it's something that's going to be spawned in the world at a later time. We don't want it just there right away at that location. And then spawn locations. The spawn location is basically just going to be an empty game object with a transform component that specifies the location, position, and all that, and you just attach the script to it. Good to go. Once you attach the script, you'll get the inspector variables that are exposed, so you can set the frequency and lifetime. And after that, it runs on its own. You don't have to do anything else with it. You just drop it in. So it's a neat, nifty little system that I think is working well in the testing I did just before I started streaming here. So let's do the test for y'all, and let's see. Save that scene. Let's see if it actually works as I'm saying it works. So I set it for 15 seconds. So let's get here. We can see both sides of the counter. And I didn't start my timer. I apologize for that, but I was going to start that so I could see. It's going in a usually long time. I'm thinking what I did is I changed the values. I guess I'm a little unclear of when you update and do the applies. Like I applied at the top of the building structure. I thought it nested down to all the child components. It would apply anything changed there, but I'm thinking it kept the original values that were 60 and 45. So it was like 60 for a spawn and 45-second despawn timer, and it respawns every 60 seconds. Oh wait, no, we're getting an error down here. What does it say? Unity exception. Find objects at the very bottom here. It's not allowed to be called from a model behavior constructor. Ah, okay. The change I made, it didn't like that, I think. Item spawn one. See, I broke the code already. I think it was this that I changed right here. I said I wasn't gonna. I was reluctant to mess with that. Let's just do that. Comment it out. Uncomment that. Yeah, so it wouldn't spawn anything then. Okay. Wait till it finishes compiling here. Alright, I think it's done. Let's get our timer ready. Got my clock open here. I'm going to hit play. As soon as I see the scene, I'll hit start. Okay, I'm starting. Hopefully in 15 seconds here, we'll see some items that are spawned. I'm going to leave them sitting here. It's been... Sometimes it seems like... There we go. Yeah, it was right at 15, pretty close. Now let's see, in about 5 seconds they should despawn. And we'll see how quickly it despawns. Boom. Okay, another 5 seconds it'll respawn the next set because that'll be 15 seconds. Yep. I'm a second off on my time because by the time I clicked I was a second off, but it should be right in about 2 seconds. Gone. Yep. So it's actually doing much better now. Just I tweaked a few things and yeah. So it'll continually spawn and respawn using the frequency and the lifetime variables as the destruction timers. And so the next thing I foresee, and we'll probably be making modifications to this later on, and this is part of the process. Obviously, it's on a set interval, which means the spawn location will spawn every 15 seconds right now. But for example, if this is let's say this is a longer spawn time. Let's say we had spawn, like items would spawn, I don't know, let's say they would spawn for like, like 15 minutes, and they would despawn at, let's say 10 minutes, so you'd have about a 5-minute time when nothing would spawn in that location. That's fine, but you know, this is great if it's getting fresh inventory and switching it out, you know, automatically. But if an item gets picked up on a 15-minute timer, if an item gets picked up right after the first minute, then that means, I guess, nothing would respawn again for 15 minutes, or do we want to start the respawn timer? I guess we don't want to restart the timer. Yeah, I was just kind of thinking this through. If we reset the timer from there, it's going to actually add more time. The time that that person took to pick it up, plus if we... So I guess it's fine the way it is, because they pick it up 7 minutes into it before it despawns. Well, that means there'll be another 8 minutes. So I guess it'll be fine. You know, I never really thought about spawning systems in games. I know how they generally work. They're gonna spawn items every so often, and if they despawn if you don't pick them up, but if you pick them up, I never knew how the spawn timers worked at that point. Was there anything special that would trigger another item like sooner? That could be a modification that maybe we don't wait. Like if somebody picks something up within a minute. Since we have what I call the difference in the despawn time and the actual duration of the spawn, in the example of this we have right now, 15 second, and 10 seconds to despawn, 15 seconds before it respawns. So basically a 5-second difference between the despawn time and when it respawns another item. That's really the wait for another item. So could that potentially be used later on with a modification to say, okay, if an item is picked up on 2 seconds after it's spawned, well, let's 5 seconds later from that 2 seconds respawn a new item. You know what I mean? So that it's or do we leave it just the way it is, and if it's picked up early, it's picked up early. But so those are things that can be worked out by you as a developer, whoever's creating the game, the team, the individual, you know, you can come up with your own way to do that kind of stuff. But the important thing is to, you know, make sure it makes sense, and obviously listen to your player base if you have a player base, and get some feedback from them, and they may have some input on that. Sometimes they have great ideas and how, you know, things could work within the game. It's just you're the guy to implement it. So we have a spawning system in place. So I'm kind of excited. I'm moving closer to where I want to be. The next thing we want to do is we want to be able to pick up items. So we need to determine how we're going to do that. How are we going to pick those items up? You know, we've got all these variables now that will come into play when we pick, like stackable is going to be the next thing that'll come into play when we pick up an item. Because if it's a stackable item, we need to stack it in the player backpack. If it's a non-stackable, we just need to add it to another slot. So the next thing I'm going to do is kind of, I'll probably do this off stream. I'm try not to do a lot of the coding off stream. I'd like to do some of that where you can see how things are implemented and you know, be able to see me work through some of this. But what I will do off stream is probably just come up with the visual side of, okay, when you hit I for inventory, how you can see what items that you've actually picked up. You know what I mean? What the screen is going to look like. And we'll do all the scripting though to make that happen, where it actually gathers the pickup, you know, portion. And so once we pick it up, we're going to store it into essentially the simplest way right now is to store it in an array. That's what I'm thinking. We just have a pickup array. Every time a user picks up an item, we pick up that array. Now we can define if we're going to have a fixed backpack size. Let's call it that. We'll just say backpack. Everybody knows what the backpack is in the games. A lot of these FPS games. So our player backpack inventory is going to be a fixed size, fixed number of slots. So we'd have automatically, when we instantiate or create our character in our game, he's going to have by default a certain number of items he can pick up without equipping an additional larger backpack, for example. We need to have an array that's going to hold those items. So I already see that, you know, let's say just for simplicity here, let's just say we're going to have a 20 slot pickup system. So we'll have 20 slots, and then we'll have our well, we're going to have, yeah, we'll have 20 slots. And then we'll have what we call a primary slot, a secondary for the weapons, primary, secondary weapon. And we'll have some what we call quick slots, which will allow us to equip some of these consumables, the first aid kits, the drinks, the bottled waters, things that we want to put in there. And we might also expand the system to have additional slots for the attachments. Like on the weapons, we've got a silencer. So that's really the only thing I have. But if I'm going to go ahead and develop additional slots for an attachment, I probably would, for the primary weapon, go ahead and develop the screen that pops up that shows not only your inventory, but it's showing your equipped items. I'll just go ahead and have one for, like, you know, the clip slot, a slot for the like a silencer, something for a scope, and you know, get those slots already built in. Even though we're not using them right now, we'll just kind of have it laid out in our design, in our visual design of how that's going to look on the screen when you hit I. And so we'll have it ready to go. And we'll work out something, maybe 20 other slots in addition to those primary, the secondary, the attachment, all that. Depending on how we lay that out, might be too many. And initially. But anyway, so we have an array that's going to have all this in it. And the way I want to implement this is at the top of the array, the first so many items are going to be the ones that are going to be mapped out to the equipped items, your primary, secondary attachments, quick slots. You know, maybe we'll come up with where it's about 10. I don't know. If we just hypothetically, if we had, of course, a melee weapon's not going to have, secondary weapon's not going to have any attachments on it, so that's one slot there. Then we have a primary weapon, and then we have, I foresee at least 3 additional slots on there. So let's hold on 1 second. I need to pause this for just a second on audio. All right, so sorry about that. I'm back. Okay, yeah. So we have one for our melee or secondary weapon, one for the primary, one for an attachment in the front of the gun, like a heavy barrel, a silencer, that kind of thing. One for a scope, one for a clip. We might want to have something under it. Usually, sometimes on your other guns, you'll have like a laser sight or something like a laser. So we could add an additional slot for that. And then we're looking at our consumable slots. And I'm thinking about having 4 just to make this an even 10, because that's 6 already between the primary and secondary with those attachments. And then we'll have an additional 4 slots for the quick slots. That's 10. And then we'll have our additional carry slots under that. So like we said, we could have an additional 20, whatever we come up with. But you know, maybe we'll just have an additional 10. It'll be, since we got 10 already for dedicated to the equipped items, and then you know, starting with the initial backpack, the default would be a 10-slot additional carry storage. So 20 slots total. But the way it would so that'd be a fixed array right there. What I'm getting at is it's going to be an array and it's going to be fixed. We're going to know total number of slots in that array. How we map out that array is up to us. But like I said, the easiest thing is to have the first 10 allocated in a certain specific order for you know, melee weapon in the first slot of the array, which is actually index 0, and then the next 5 for the primary weapon, which would be the weapon itself, plus 4 attachment slots. And then the 4 quick slots should be, at that point, it would be 6, 7, 8, 9, slot 6, 7, 8, 9. So 0 through 9 would be the first 10 slots of the array. And then the remaining 10 would be just items that can be picked up. Now, the array itself, we're going to have to build somewhat of a very simple struct, what's called a struct, or a data structure, to represent the data that's being stored in each array element. So obviously we need to know the item, what the item is, and that's not going to be difficult. We've got, you know, the item name. We'll store that. It's going to be the item name, which is the name of the prefab. So we'll know exactly what it is. But the other thing that we need to have is a way to track in the event it's a stackable item, a way to track the stacked item count. So that would be the second variable. And so there's at least going to be 2. It'll be the name and the stack count is what we'll call it. And that would be at its simplest. Those would be the 2 things we need to track for each element in the array. So it would be what we call a multi-dimensional array. It's a 2-dimensional array because there's only two 2 dimensions to it, which, 2 for each element. I'm trying to think if there's anything else at this point that we would need to consider when creating a simple inventory, player backpack inventory system. I mean, other than the fact of knowing what the item is and whether it's stackable and tracking the stack count, we already know whether it's stackable or not. That's going to be in the item prefab itself. It's tracked as a variable, so we'll know what that is. And actually, these objects can be, when we collide with an object for a pickup, the object itself, because it has that script, the item attribute script attached to each individual object, all those values, whether it's stackable or not, and what other values on it, is stored in there. So essentially, we might even use the actual object, the game object. That'll be the type, the data type of the first type of data that we need to store, and then we'll have the secondary would be the stack count. And so, yeah, I guess we'll have to implement it and see. And I don't really foresee anything more. I can't really think of why we would need to track anything more than that. You know what I mean? That's all we need to do is, track the count. So items that are not stackable, of course, the second variable, which is the stack count, will always have a value of 1, which will just store that's the one item in there, but it's not stackable. So when, basically we'll have to write some functionality that when let's say a player already has an ammo pack in one of their slot backpack, and they go to pick up another, before we just add it to another slot in the backpack, we're going to have to write a function that actually searches the current backpack inventory, and it's going to find a matching item. We're going to find another ammo box that's already in there, and then we're going to check its stackable property. Is it stackable? And if it is, we won't actually add it as an item to the backpack. We'll just increase the second dimension of that element's stack count, by 1. So that's how we'll track those and keep those organized. Now, if it's an item that's not stackable, as it's searching, for example, like a pistol, if it's picked up, it's not stackable. Even though it'll find a pistol in the inventory if they have it, it'll see it's a non-stackable item, so it'll automatically add it, like to the backpack. And so we'll have a function called just add item, and so we're going to create a script called, I'm thinking it's going to be called player inventory. It'll be the script name, or maybe player inventory manager. We'll just kind of go with that. We're trying to do this manage because it's going to probably have additional functions that we'll add over time for the player inventory. So we'll have more than just the simple stuff, but it'll continue to grow as we go, and we'll add more complex functionality to it. But initially, it's going to be pretty simple. And so yeah, we'll add that stuff to it and update the count if it's stackable. If not, we'll add it as a new item. We'll have to have a check in there to see even if the item can be picked up and added. Maybe it's not a stackable item, we're out of slots. We need to take that into account. So as part of our player inventory manager, we're going to have inside that class, we'll have to have a variable that represents the backpack size, the slot size. And so that variable will be set. And we might even want to initially, just to prepare for future backpack upgrades later on, we'll identify our backpack by a name. We'll have a name field in there so we can call it. We'll have it in there so that also it can be identified in the system as whatever our standard or normal backpack or basic, hiker's backpack, whatever we want to call it, but it'll have a standard slot size. So yeah, we're getting close. So once we get the pickup part done and get the inventory, the backpack thing going, that almost has to be developed at the same time. And we could do the pickup portion, like the collision detection on these. We could actually start writing out that code where, when the player gets up near it. Again, it's not going to be an automatic pickup. I want to have a key that's pressed to pick up the item. And there's a game that I have played where I've gotten used to it. E has been kind of the pickup. I is inventory. E is the pickup. And so we'll do that. I don't know if I'll have like a delay, where some games have a delay. You got this little circle that's going like a clock, and you got a certain amount of time. You got to hold that button before it actually picks up. An item should be able to be picked up pretty quick. I can see opening a chest or opening up a crate. Takes a little more time. Maybe have some kind of animation for that, but we're going to do a simple pickup. We'll have a little bubble that pops up when the player collides with the item. You'll get a notification on the screen. Press E for pickup, or E. Yeah, press E to pick up. And I also want to. I don't know if I want to automatically do it because it may clutter the screen real estate, but I almost thought about setting up a little bubble caption that pops up when you interact with an item or get near it within its pickup zone, where it tells you more information about the item. Because sometimes, you get to know the items after a while, but I'm trying to decide if we need to worry about that. Because we could always have it, that could be part of the player inventory system, where once the item's in their backpack, if they had eye to look at it, you hover the mouse over an item, it gives you details on that item. That's probably what we'll do. So we'll come up with a layout that works. It'll be a certain area of the screen, it's part of the inventory, player inventory view that comes up. Whereas you hover over items, there's a description maybe down at the bottom. And there's the bottom part of the screen gives you information about that item just by hovering over it. And then on the right side, I'm envisioning where you can see the slots where you kind of drag and drop your attachments in your primary, secondary weapon. We also got to think about when you're dropping an item into a slot that already has an item. In most cases, in most games, it does an item swap. So those are some of the things that we need to be concerned with. So I'm jotting these things down. Inventory manager. Max slots. Just writing down 2D array for item representation. We also need so just some notes to go on. But like I said, what I do want to do is come up with this will be off the stream here. I'll come up with the visual look of the player inventory screen that pops up. That would include, an information or the slots and, of course, the information areas that will be needed to display and show the items that we pick up and help us manage our inventory by dragging and dropping. Like I said, the scripting side of that, we'll work on it on the stream so you can see how we can take something like that and then bring it in and make it all work and have this kind of magic going on. So anyway, yeah, we're getting closer. Getting very close. I almost want to. Well, here's the next thing we're going to need to do. It's going to be a big step, really. Is haven't really fooled too much with the animation controller that's built into this this person I'm using right now in this game. This Evan, I think his name was. I forgot what his name was, but I'm gonna need to work with that and figure out how all that works. And when you draw your weapon, how to make them. I'm probably gonna have to do some. I'm sure they're not gonna have the animations I need, so I'll have to work in the animator portion of Unity and come up with some custom animations for this player controller here. But I don't know if I want to use Ethan. That was his name. If I want to use Ethan, the one that's built in, just because he's kind of wonky. It just, I don't know. It seems like it's not quite fine tuned really well. But there's another one that I had seen that I mentioned before by Invector. They have a third-person controller and shooter. So it's designed for FPS and supports melee, primary, secondary weapons. As far as the animations go, it has a lot of that built in. There's still some tweaking that I would have to do, but I played around with one of their demos, and they're at least in the the player controller they had, it worked flawless. It ran a lot more fluid. It's easier to maneuver. It already had built in the mouse movement, but this one is like when I try to turn, it's like it jerks around too much. I got my speed button on right now, that's why it's running fast. That was one modification I did do. I don't like the way he leans. Like, watch when I turn, I'm just hitting the well, I guess he's not doing the leaning now. There he goes. As you turn the mouse, he kind of leans a little bit, and his animations get kind of wonky. And it's like he's so, it's kind of choppy in a way, unless you're looking straight ahead. I'm looking straight ahead. I don't know. But yeah, I've been talking for a while now, and we have not locked up once. This is a good sign that our spawning system is, let's cross our fingers, bug free at this point. We may inject additional bugs in the future as we modify the code, but as of right now, the way it works, it's fine. And I think I'm going to keep it the way it is. When we pick up an item, it'll be destroyed at that point, just earlier before the actual timer, which it will not affect the spawning system, because that particular destroy feature is, like I said, it's built into the actual item when it spawns. So the item controls that, not the spawn. So our spawn's still going to go on its normal interval whenever it needs to respawn, and that'll work out perfect. Of course, 15 seconds is too frequent to respawn. We'll come up with some reasonable things, but during testing, we'll probably keep it at a low value just so we can pick up a lot of items quickly. And yeah, I might even look at getting another structure, something that's a little bit more open that we can run through, like something maybe with a second story with stairs, something we can run up through, and put a bunch of spawn locations, within the building, and we'll see how that goes. So, yeah, I guess we'll cut it off at this point. I just wanted to kind of touch up on the changes we did in the spawning system and show that it's actually working now. And yeah, we're making some progress. So this is kind of the second feature I added where we kind of ran into a snag where I kind of had to take a couple of days to kind of knock my head around and figure something out and play around with stuff. And so occasionally I'll go what I call binge coding. I'll have to get off and try different things, and that's, you do what it takes. If you're going to be dedicated and want to get this done, you're going to run into roadblocks. You're going to run into a bug, a glitch that's going to drive you nuts or crazy. But step away for it for a while. Come back to it the next day. Just sometimes you got to take your mind off it and just come back to it and rethink, and then just retrace your steps. Even if you don't come back with another solution, you just need to go back with a fresh start, a fresh set of eyes, and look through all your code, and then you start realizing things that need to be done, like the fact I realized the lifetime was initially set to 0, so it was really just despawning before I even had a chance to set the value to what it needed to. Because the item was already active, I needed to make sure the item was inactive as it was being spawned into the world, and then, you know, if there's any additional properties that need to be set them, and then activate the item after all the changes have been made to that object. And so keep that in mind. That's the main lesson to learn in this, so you don't run into the same mistake I did. I definitely won't run into that again. Yeah, I'm almost looking at setting all my objects that way, even buildings, and then maybe even, I think there's a layering or a grouping thing we can do where we can spawn items based in groups. So I would maybe do waves, like once the game actually loads and it renders the world, then it would spawn all structures first, get those spawned in by activating them. They would already be loaded. It would be a, you know, we'll set up a nice way to load this and show progress loading game objects, and it would spawn those, and then the second after that, then it would set up spawns and do all those at one time. And you know, so anyway, those are things to worry about later. It's not really a big issue right now. It's not like I really see the game rendering. Sometimes you see a world rendering in front of you, all the components are not there, and that can be due to frame drop, or your computer's slow. It doesn't have the hardware to keep up with everything, so you'll see that rendering. But other times it could be there's just so much going on, and it's all like, if I were to drop, you know, thousands of objects in here, and if my computer's not fast enough, you'll actually see them being rendered in, because it would be best from the programming side to instantiate all these objects, get them loaded into the scene, maybe not visible, and then have a, you know, a function that flips a switch and activates everything, because that's very fast. That's going to be fast. Once everything's in there, all you're talking about is rendering stuff. You're not actually having to load mesh data and other data, you know, like inventory items and other things that are maybe resource intensive, loading all the meshes into memory. So once that's all there and it's in there, then you can just flip the switch to set all the active flags on all your objects, and the scene would almost instantly appear. So I'm not going to worry about that now, but if I get to the point where that becomes a problem, we'll definitely look at doing that. So thanks for joining. We'll see you on the next stream, and hopefully I'll have the UI built for the player inventory screen, and we can start scripting that along with the pickup code that we need. So thanks again. I hope you enjoyed it.